All right, so today we're going to be talking about simplifying expressions. Now, we've already learned about how to write expressions in the real world. And unfortunately, sometimes in the real world, expressions aren't maybe in the simplest form that they need to be in. So it's really important that we know how to make things easier by simplifying expressions because everybody wants things to be easier, right? So first we're going to do a quick review just of the parts of an expression. Then we're going to get into actually simplifying expressions, what that means. We're going to be representing and simplifying these expressions with our algebra blocks, which you learned about in the investigation. And then eventually at the very end, we'll be talking about how to apply those expressions and simplifying to real life situations so that you can really use this math in your everyday life. Make sure as we're going through that you're taking all the notes that you need to and you're really, really listening to the video. It's very, very important. This is the step where you are learning what to do. So make sure you're really taking your time to do that. Okay? If you're confused, make sure that you're asking questions, asking your teacher for help. Okay? But the first step is to really make sure you're paying attention. Okay, so we should have our simplifying expression notes loaded into GoodNotes. Let's go ahead and turn to our first page here. So the first thing we need to discuss are the different parts of an expression and what we call them with math vocabulary. We all know that learning math can sometimes be like speaking another language. So it's really important that when your teacher uses these words, you understand what they mean and you are able to start using these words when you're talking about math expressions. So right here we've got the expression 4x plus 12. Okay? And the first thing that we're going to be talking about here is this 12 off to the side. This 12 off to the side here is what we call a constant. And so we're going to write that in this box right above 12. Constant. Make sure you're spelling this correctly. Okay. A constant is a term without a variable. Okay, so once again, a constant is a term that doesn't have a variable. So you can see the 12 has no letter attached to it, so that will be considered a constant. Now our other terms here, the 4x and the x, both have a variable attached, so we would not call those constants. The next thing we're going to talk about is something called like terms, okay? So you can see here that 4x and x both have an x in them. And when we represent this with the algebra blocks, you'll see that they're both represented with the same kind of block, the x block. So we would say that 4x and x are like terms. Okay, if you're thinking about the algebra blocks, it means they're represented with the same kinds of blocks. Okay, so like terms contain the same variables. To the same power. And basically what that means is that x and x squared, or x to the second power, would not be considered like terms because they're raised to a different power. So once again, x and x squared, that's x squared, are not like terms. Okay. The next thing that we're going to talk about is how many terms there are in this expression. And terms are any part of the algebraic expression. And you can see here that we've got 4x, x, and 12. each one of those is considered a term. Let's write that down here. Oh, get my shapes on still. So remember, a term is any part of the expression. And in this example, we could say that there are a total of 3 terms: 4x, x, and 12. Okay, the last variable we need to discuss is something called coefficients. Go ahead and say that to yourself out loud. Coefficients. One more time. Coefficients. It's a weird sounding word. Here's how it's spelled. I know, it's a long word, right? Make sure you take your time and get it written down correctly. Okay? So coefficients are when you have a variable, if the number that's attached to the variable is considered the coefficient. Okay? So in this case here, if we look at 4x, okay, we can see that the coefficient is 4. That's the whole number attached to the variable here. Okay? Now, this x over here is a little sneakier because there is no number in front of it. But in math, we can assume that if there's nothing written before it, it's like there's an invisible 1 right there. Okay? So once again, if you just have the variable x, the coefficient is 1. Okay? So be careful of that. There's always a coefficient there, even if it isn't written. Okay? That's when you can assume that it is 1. And let's write down our definition for coefficient. Okay? Before we move on. So coefficients are the numbers attached to the variables. Okay? Okay, so that concludes our first set of notes on the vocabulary terms of an expression. We've talked about like terms, which are terms that contain the same variables to the same power. We've talked about what a constant is. A constant, remember, is a term that doesn't have a variable. So in other words, just a regular old number. A term is any part of the expression. So remember, in our expression 4x plus 12, we've got a total of 3 terms. And then last but not least here, the coefficients here are 4 and 1. Okay, let's put our knowledge into action now. Go ahead and swipe the page, and we've got our first expression here to try. 6n minus 7n minus 4 plus n. Okay, and what we're going to be doing here is labeling the terms, the like terms, the coefficients, and the constants. Let's start with the terms. We can say the terms are 6n, remember these are the parts of the expression, negative 7n, yes, that's right. Since there's a subtraction sign here, we have to group that with our 7n. Okay, so that's called as negative 7n. Okay, negative 4, once again, because the subtraction sign is in front of it. And our last term is n. Okay, so again, our terms are 6n, negative 7n, negative 4, and n, which means we have a total of 4 terms. All right, the next thing we're going to take a look at is the like terms. Remember, these are terms that have the same variable to the same power. Here I've got 6n, and so I'm going to look for any other n's that I see that aren't to a different power. I've got negative 7n and positive n. So I can say my like terms here are 6n, negative 7n, and n. Okay, all of those would be considered like terms. Now my other term here is negative 4. If I had other whole numbers, I would say that those are like terms to negative 4. Okay, but in this case, we just don't have any. Next thing is our coefficients. Okay, well, 6 is attached to n, so that's going to be my first coefficient. -7 is also attached to an n. Okay, we don't do this for whole numbers, so skip -4. And then last but not least, that n. What is the coefficient if there's no number written? You got it, it's 1. Okay, so our coefficients are 6, -7, and 1. Okay, last but not least, our constants. Remember, our constants are any terms that don't have a variable with it. In this case, our constant is -4. We just have 1 in this case. Sometimes there's more, sometimes there's less. All right, let's try another one. Now we've got the expression 9y minus 4 minus 11y plus 7. Again, let's start with our terms. So pull out each part of the expression. We've got positive 9y, -4, -11y, and positive 7. In this case, let's look now at our like terms. Remember, like terms have the same variable to the same power. I see 9y and -11y are both y's, so I can list those as like terms, 9y and -11y. Now the tricky thing here is we actually have another set of like terms. Do you see them? That's right, it's -4 and 7. Whole numbers are also considered to be like terms, so we can list another set of like terms to be -4 and 7. Okay, anything that doesn't have a variable attached you would group together. Okay, next thing we're going to talk about is the coefficients. Remember, coefficients are numbers attached to variables. So in 9y, I can write down that one coefficient is 9, and in -11y, my other coefficient is -11. Next, I need to list my constants. Remember, constants are numbers that do not have a variable attached. In this expression, we have 2. We've got -4 and positive 7. And that's how we've organized that expression. We're going to try one more together. 3x plus 2 minus 10 minus 3x. Once again, let's start by listing our terms. We've got 3x, 2, -10, and -3x. Okay, a total of 4 terms. Now let's take a look at our like terms. I'm going to start with my x's. I see 3x and I see -3x, so I can list those as like terms. Are there any more? Yes, there are. Hopefully you can see that 2 and -10 are also like terms, so let's list those below. 2 and -10. Okay? Next is our coefficients. Remember, coefficients are numbers attached to the variable. So in this case, our coefficients are 3 for 3x and -3 for -3x. Okay? Our constants, remember, are any numbers that do not have variables attached. So these numbers would be 2 and -10. Now that we've identified the parts of an expression, it's time to start really talking about how to simplify these expressions to make them easier for us to solve. We're first going to learn to simplify expressions with algeblocks, and then we'll move on to simplifying without the algeblocks, since you can't really walk around the rest of your life with a bag of algeblocks, but it's definitely a good start to help you understand the process. Okay? The first step when you're simplifying with algeblocks is to model the expression with algeblocks. Okay, the next thing that we're going to be doing after we model the expression with algebraics is combining like blocks, or in other words, like terms. And then our third and final step is to write the simplified expression. Okay, so those are our steps with simplifying with algeblocks. Alright, so our first expression we're going to model is 4x plus x. You will need a bag of algeblocks and an algeblocks mat with a plus sign and negative sign on it. So if you don't have those, please pause the video and get them from your teacher. So remember, our first step is to model our expression, 4x plus x, with the algeblocks. Okay, so you should make sure you have this mat. Okay, and I apologize, it's a little dark. Make sure you have this mat in front of you. Before we start, let's just really quickly review the different kinds of blocks we have. So remember, we first learned about this green block. Remember, that represents 1. So whenever we're representing regular numbers, we're going to use that green block. Okay? Remember that this this yellow stick actually represents x. Okay? And then the orange stick represents y. So those are our two variables. If we needed to represent 2x, we will put down 2 yellow blocks. Okay, if we needed to represent 3x, we will put down 3 yellow blocks. And then remember also that our yellow square represents x squared, or x to the second power, and our orange square represents y squared, or y to the second power. Okay, so those are the basics of the algeblocks. Now let's see what we need to model our first expression. Let's flip this back over. Okay, pull this down one bit. Okay, and you'll also see on your algeblocks basic math that you have a positive side and a negative side. Okay, so you want to make sure that you're also noting the sign of the variable you're representing. If it has a subtraction sign in front of it or a negative sign, you want to make sure you're putting it on the negative side, or if it's a positive or with addition, you need to put it on the positive side. Okay, so let's just quickly go back. Remember, our expression is 4x plus x. So I'm going to start by modeling positive 4x. I'm going to model positive 4x by putting, that's right, 4 x blocks on the positive side of the mat. Okay, that represents my 4x. Next, I'm going to take one more x to represent that 4x plus x, one single x. Remember, one x by itself means 1x. Okay, now I'm going to go ahead and take a picture of this. So you should be doing this on your own mat and take your own picture. And we're going to drop that into GoodNotes. Okay. Here we go. So we've got our beginning expression now. This is what it looks like, 4x plus x, before we simplify it. Now our next step is to combine like terms and take another picture. So that means I'm going to combine any blocks that are the same. This one's pretty easy. I can see that all my blocks are the same, so I'm simply going to combine my x with my other 4 x's. Here's my expression now simplified. Once again, take a picture. And we're going to drop it into GoodNotes. Sorry about that. Resize. And there's our picture. Okay, now our third step here is to write the simplified expression with numbers. So I'm going to take a look here and see that I only have positive values represented, and what I'm showing on that block is 5x. So I can say that 4x plus x, my original expression simplified, is 5x. Okay? So in other words, you're combining any like blocks or like terms that you see. Let's try another one. Okay, this one's a little bit harder, but we can do it. We've got 2x plus x minus 3 plus 4. Okay, remember step 1, model with the algeblocks. So let's pull up our mat. So let's just refresh our first steps. We've got 2x and that is positive, so I'm going to put 2x over on the positive side of my mat. Then I had a plus 1 single x, so again I'm going to put 1 single x over on my positive side. Then I've got minus 3 plus 4. So to show minus 3, I'm going to put 1, 2, 3 green blocks on the negative side of the mat, and then I'm adding positive 4. So I'm going to put 4 green blocks on the positive side of the mat. Okay? And I'm going to go ahead and take a picture. Okay, now I'm going to go back to my mat and I'm going to combine my like terms. So again, I'm looking for any blocks I can combine that are the same. Can I combine a yellow and a green? Nope, those are not the same block. So see that? Don't combine the x's with the regular numbers. They're not the same block. Woo, not the same block. Don't combine those together. But I do see some green blocks on the negative side and on the positive side that we could combine. Now remember, one negative and one positive is going to get you back to 0. That's right, big fat 0. So let's start making our 0 pairs. Negative 1 plus positive 1 is going to be 0, so I'm going to take those off my mat. Another 0 pair. Negative 1 plus positive 1. Swipe those off. Negative 1 plus positive 1. Swipe those off. Okay, well I've combined all the green blocks that I can, and I'm left with one positive green block. Now let's look at my x's. I've got 1, 2, 3 total x's here, and I can go ahead and combine those together because they're all the same kind of block. Let's think, is there anything else I could simplify? No. Remember, you cannot combine an x with a green block. They're not the same block, okay? So let's take a picture of our simplified expression. Okay, so here's our picture of our simplified expression. And remember, our last step is to now write the simplified expression with numbers. Okay, so I can see from my picture that I have a total of 3x showing, and they're all positive, plus positive 1. Okay, so if we go back to our original expression, remember we had 2x plus x minus 3 plus 4. Remember, 2x plus x were like terms, so those became 3x. We also said that negative 3 and positive 4 were like terms. When we added negative 3 plus positive 4 together, we were left with positive 1. So that's how we have a simplified expression of 3x plus 1. This is the expression in simplest form. You cannot make it any simpler. Okay, let's try another one. Now we've got negative 1 plus 6x minus 5x. Remember again, our first step is to model this with the algebra blocks. So I've got negative 1. I'm going to model that with one green block on the negative side of the mat. Okay, then I've got positive 6x. So I've got 1, 2, 3, 4, 5, 6 positive x's, and then I believe I'm subtracting 5x, right? So we're going to put that in minus 5x on the negative side of our mat. 1, 2, 3, 4, 5. Aha. Okay? So here is my original expression. Negative 1 plus 6x minus 5x. Okay, remember our next step is to combine like blocks or like terms. So let's see what we can combine. Well, I see a lot of yellows here that we could combine, right? But remember, some are positive and some are negative. So just like with the green blocks, when I combine one positive x with one negative x, that makes 0, 0, 0, 0. Okay? One positive plus one negative equals 0. Okay? So I'm going to start making my 0 pairs with my x's. Okay, remember one positive, one negative, take them off, that's a 0. One positive, one negative, take it off. One positive, one negative, take it away. One positive, one negative, take it away. One positive, one negative, take it away. Okay, I've got nothing left to combine here to make 0 pairs. Now, is there anything else I can combine here that's like terms? I don't see any other blocks that are the same, so I know my expression is simplified, so I'm going to take a picture. And go ahead and drop your picture into GoodNotes. Alright, now remember the last step of this is to write the simplified expression with numbers. So looking at my picture here, I can see that I have -1 plus x represented. And just because we're awesome mathematicians, we're actually going to flip the order and write the variable first. For some reason in algebra, that's just considered the proper way to write things, just like when you capitalize the first letter in a sentence. So we're going to write this expression simplified as x minus 1. Okay, let's review. We started with -1 plus 6x minus 5x. We said that 6x and minus 5x were like terms. We combined them, made some 0 pairs, and we're left with positive 1x. Okay, our -1 had nothing to combine, so we dropped that down into our simplified expression of x minus 1. Remember, we can't combine x's with regular old numbers because they don't represent the same block. They're not the same term. Alright, let's try another one. This one's going to be a little trickier. We've got different variables in here to represent 2y plus 3x plus 2y plus x squared. Okay, let's go to our mat. Alright, so once again we're starting with 2y. Remember, y is represented with the orange sticks. Okay, we need 2 of those on the positive side to represent 2y. Alright, then we're going to represent positive 3x. 1, 2, 3. Then we've got another positive 2y. So I'm going to put 2 more y's on my positive side. Okay. And the last thing we have is x squared, which, remember, x squared is represented with the yellow square. And again, that's also positive. Ooh, we're in a positive party over here. Okay, go ahead and take your picture. All right. Now, remember, our next step is to combine like blocks. Okay. So, we go over here. Let's see what we can combine. Well, we can combine all our x's together, right? We can definitely combine all our y's together, and everything's positive, so don't have to worry about 0 pairs. Now the question here is this x block the same as the x squared? They don't look like the same block to me. That's because they're not the same block, okay? X squared cannot be combined with regular x's. They're different, okay? It's a common mistake. Make sure you're not combining x's and x squares. So this is our expression simplified. So again, let's take our picture and drop that into GoodNotes. Okay, remember our last step is to write the simplified expression with numbers. So, we're going to start with our x squared plus 3x plus, we've got 4y showing. Okay, so our simplified expression is x squared plus 3x plus 4y. Now, one important thing to note here is we do not combine x's with y's when we're adding or subtracting them together. Okay, you can't combine x's and y's, they're not the same block. Okay, so once again to recap, we said our y's were like terms. We combined 2y and 2y to get our 4y. 3x dropped down and x squared dropped down because we could not combine those with anything else. So our expression simplified is x squared plus 3x plus 4y. Alright, I hope you're starting to get the hang of this, but let's try another one. Here we've got 7x minus 2 minus 7x plus 6. Alright, let's pull up our camera and get that modeled. So we're going to start again with positive 7x. So I've got 1, 2, 3, 4, 5, 6, 7. Okay, so that's our 7x. Let's go back and check. Okay, negative 2, that's minus 2, negative 2. Okay, 2 greens on the negative side. Then we've got negative 7x. So 1, 2, 3, 4, 5, 6, 7 x's on the negative side. And last part is plus positive 6. Okay? 1, 2, 3, 4, 5, 6. Okay. Now, let's take our picture of our expression. Drop that into GoodNotes. Okay, now let's go back and see what like terms or like blocks we can combine. Well, I definitely see a lot of zero pairs we could make. Let's start with our x's just to get them out of the way. Remember, one positive x and one negative x makes 0. 0, 0, 0. Okay, one positive, one negative, taken away because it's making 0. One positive, one negative, 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 0. Whoa, guess we're done with our x's. Okay, now let's do the same thing with our green blocks. One positive, one negative, 0. One positive, one negative, 0. I think this is pretty catchy. One positive, one negative. Maybe I can make a rap song out of this. What do you think? No? I'll keep working on it. Okay, so looks like all we're left with is positive 4. Let's go ahead and take a picture of that. Okay, we've got our picture. Last thing, write the simplified expression with numbers. Woo, this is an easy one. It is 4. That's right, ladies and gentlemen. Our expression went from this long thing up here to 4. See, simplifying expressions makes your life easier. Do it. Okay, let's just recap right here. Okay, we said 7x and negative 7x were like terms. We combined them. They all went away. We also said that negative 2 and positive 6 were like terms. Negative 2 plus positive 6 leaves us with our simplified expression of 4. Okay, let's try the next one. Just 2 more to do with the algebra blocks. Okay, 2x minus 4 plus 3x plus, did we do this one already? Nope, just kidding. Let's keep going. Okay, 2x minus 4 plus 3x plus 2. Step 1, you know it by now, model with the algebra blocks. Let's do that. Okay, So I'm going to start with positive 2x. 1, 2, positive x is on the positive side. Then I believe it was, yep, minus 4. 1, 2, 3, 4 on the negative side. Then we've got 3x plus 2. So another positive 3x. Okay, plus 2 positive. So here's our original expression. Let's go ahead and take a picture. Okay, next thing we need to do, combine like blocks, or in other words, like terms. Let's see here. Well, we can definitely combine all our positive x's, right? Okay, put those together. Now let's take a look at our greens. I see some zero pairs we could make. 1 positive, 1 negative, take it away. 1 positive, 1 negative, take it away. Okay, so here's our expression simplified. Remember, we cannot combine yellows with greens, not the same block. Okay, go ahead and take a picture. Drop that into GoodNotes. Alright, last thing we need to do, write the simplified expression with numbers. Okay? Okay, so for our x's, we've got a total of 1, 2, 3, 4, 5 positive x's shown here. Okay? So we're going to write 5x minus 2, because that 2's on the negative side. Okay? Oop. Hold on a minute here. Doesn't seem to be popping up on your screen. Make sure this is on. Oop, let me see here. Nope. Seem to have a glitch. Alright, we're going to stop the video here and pick up with the second video with the second part of this lesson. Stay tuned.